Hello everyone, you are welcome. Today we have a new beautiful geometry math problem. Let us here we have given a right angle triangle, an isosceles triangle, and there is a circle inside the triangle. We have given two sides length of the triangle and we have to find out the area of this circle. Now to solve this problem, first of all let us suppose this is our triangle A, B, C. And let us suppose this side is equal to small a, which is 2 units, and this side is equal to b, which is also 2 units, and this side is equal to c. Now the length of this side is not given. Here we will try to first find the length of this side. As this is a right angle triangle, so here we can find the value of c using the Pythagoras theorem, which states that c square is equal to a square plus b square. So by using Pythagoras theorem we can write c square is equal to a square plus b square. So here this value of c is not given. The value of a is 2 and the value of b is also 2. So this will become c square is equal to, this is simply 4 plus 4, which is 8. Here we will take square root on both sides. So the value of c will become, here we can write the square root of 8 as 4 times 2. The square root of 4 is simply 2 times square root of 2. So therefore the value of c is 2 times square root of 2. So this is the value of c and this is the length of this third side. Now what is our next target? Our next target is to find out the radius of this circle. This is because here our target is to find the area of this circle, but the area of circle is pi r square, where we need the value of r. So to find out the value of r, let us suppose this is our center of this circle, and let us suppose this is point D, this is point E, and this is point F. Here we will join this center. Let us suppose this center is O. Here we will join this center O with point D, E. So this will become, now after joining center with D and E, as this is the radius of our circle, so let us suppose this is R, this will be also R. Look into this one figure, DOEB, this is a square, and as we know that all sides of a square are equal, so this all side will be R. Look into this side BC, here the length of BC is 2 units, but here the length of BE is R. So what will be this length EC? This will be 2 minus R units. So here this length AB is also 2 units. So this BD is R, so this will become, this AD will be 2 minus R. Here in this state we will use the two tangents theorem result, which states that if we have two tangents to a circle from the same external point, then the length of the two tangent line segments will be equal, congruent. So here the length of this EC tangent is 2 minus R, so this will be also 2 minus R. Now this tangent length is AD is 2 minus R, so this AC will be also 2 minus R. Now look at to this side AC. Here the length of this AC is C, which is 2 times square root of 2. But we can also write this AC as, here the AC is the sum of AF plus FC or CF. Here the value of AC, as we find out, it was 2 times square root of 2. This is 2 times square root of 2 is equal to, and the length of AF is 2 minus R and CF is also 2 minus R. So this will become 2 minus R plus 2 minus R. Now let's simplify this equation. This is 2 times square root of 2 is equal to 2 plus 2 is 4, and minus R is negative 2R. Here we will take this to the left hand side and this to the right hand side, so this will become 2R is equal to become 4 minus 2 times square root of 2. Here we will take 2 common, so this will become 2r is equal to, this will become 2 minus square root of 2. We will divide both sides by 2. So the final value of r will become, r is equal to 2 minus square root of 2. So here this is the value of r and this is the value of the radius. So here the radius of this circle is 2 minus square root of 2. But here our target is not to find out the radius of this circle. Our target is to find out the area of this circle. So therefore we can write the area of this circle as area of circle is phi r square. So substitute the values here. The value of phi is about 3.14 up to 2 decimal places times the value of r is here 2 minus square root of 2 whole square. First we will try to find out the value of this square number. So therefore we can write this square number as 2 minus square root of 2 whole square. So we will expand this using a minus b whole square identity, which is equal to a square plus b square minus 2 times ab. This will become 2 square. 2 square is 4 plus square root of 2 square minus 2 times square root of 2. So to simplify this right hand side, this is 4 and this will become 2 minus this is 4 times square root of 2. Now further this will become 6 minus 4 times square root of 2. Here we will substitute this in place of 2 minus square root of 2 whole square. So this will become, the area of this circle will become, that is 3.14 times 6 minus 4 times square root of 2. Now after simplifying this right hand side, it gives him about 1.08 unit square. So finally the area of the above circle is 1.08 unit square. So therefore we can write the area of this circle as 1.08 unit square, which is our required answer and required target. Last, don't forget to subscribe my YouTube channel for such a more interesting geometry math problems. Thanks for watching.